Assalamu alaikum. Sometimes the data is available to us only in the form of frequency distribution table, and we call this data as grouped data. In this video, we are going to see how to compute the descriptive statistics for the grouped data. So as I said earlier, sometimes the data may only be available to you in summarized form and not the exact values of data. The summarized form is presented as the frequency distribution tables, where we have class intervals, and only the frequencies of values contained in respective classes are given. Such data is known as grouped data. Now the question is, when the exact values of the data set are not available, how can we compute the summary statistics? And this is what we are going to learn in this video. So if you have grouped data available to you in form of class intervals and their frequencies, and if you are required to compute the mean of it, we need to use the class interval values to compute the mean. Consider this example of the time taken by 60 malware detectors to complete scanning of a large file. So here we can see that we have 5 class intervals. Class intervals are frequency distribution tables ki construction we've already seen in one of the earlier videos. You are already familiar with the class boundaries and class intervals. We know that this is for every class, this is the lower class limit and this is the upper class limit, and which essentially means that the lowest value that this class may contain is 1, and the highest value that can go into this class interval is 20. So for the calculation of mean from the group data, we need to have one additional column in this frequency distribution table, which is min, and we can calculate it from the information available to us. We have the class intervals, which include the upper and lower class limit. The midpoint of a class gives the central location for the interval, data in that interval. So since we know that the highest value that it can contain is 20 and the lowest value it can contain is 1, this class has values which range from 1 to 20. And the central location of this data is computed by taking the average of these values, which is we add the upper and the lower class limits and divided it by 2 to get the midpoint. And this is the expression for it. And we do it for all of these class intervals. The frequencies of these classes are already available in the frequency distribution table. And we know that if we sum up all the frequencies, we get the count of values in the data set. Now, in order to compute the mean for this grouped data, we need to use the midpoints and the class frequencies. And it is done by computing the product between the midpoint and the respective frequency of the corresponding class to get these values, and then we add them up. A BA value is an estimated sum of all the values in the data set. Of course, it is not the exact sum because we do not have the exact values available to us, but it is only an estimation of the sum of all the values. And now the only thing we need to do is to divide it by the total count to get the estimated mean for this group data. And this is how we do it. 3,263 is the sum of all these values, and these values are computed by multiplying the midpoint and the class frequencies. And then we divide it by 60 to get 54.46 as the average time for this data set, which was available to us only in summarized form. Similarly, we can do some calculations to estimate the median for grouped data. But for median, we know that it is the one entry in the data set, which is the midpoint, and 50% of the values are greater than this value and other 50% are smaller than this value. And for this, we need to identify the interval which might be containing the midpoint. The median position is calculated using this expression, which is n plus 1 divided by 2, and this is the position which contains the median value in the arranged data set. Now, to compute the median for group data, we need to compute the frequency, cumulative frequency column. Here we have the same frequency distribution table. We have class boundaries, we have class intervals, we have the midpoints, although we might not be using the midpoints in this calculation, and we have the class frequencies. We need to compute the cumulative frequencies. Cumulative frequencies calculate करने का तरीका already हमने एक वीडियो में देख चुके हैं. It is the frequency of this class and the frequency of the classes preceding it that we add them together. So for the first class, the frequency is 9. For the second class, the frequency is 12, but the cumulative frequency is 12 plus 9, 21. For the third class, it is 9 plus 21 equal to 30, and so on. The cumulative frequency of the last class should be equal to the total frequency, total number of elements in your data set. A median class, fine, हमारे पास intervals हैं. We do not have the exact, the actual values in the data set. तो आप median position to identify कर सकते हैं, because for that you only need to know the count of values in the data set, which we know as 60. So 60 plus 1 divided by 2 is going to give you the position of the median value, but values themselves are not available. तो हमने intervals में से identify करना है कि कौन सा ऐसा interval है जिसमें median value exist करती हो. Median position comes out to be 30.5. 60 plus 1 divided by 2 gives 30.5. Now we need to identify the class which might be containing this median value. और इसके लिए हम cumulative frequencies को use करें. अब 30.5 value is a value which is greater than 30. तो जिस class की class interval की cumulative frequency is greater than or equal to this value, that will be identified as the median class. The first class interval, which has cumulative frequency which is greater than or equal to the median position, will be identified as the median class. So here 30.5, we get this class as selected as the median class, because of course this median position cannot be existing in this interval, because it contains only up till the first 30 values, and we need to find the value at this position which is above the 30th value. So we choose this class as the median class. And now we use this expression to compute the median for this grouped data. The values, the notations in this expression are explained here. L is the lower class boundary for the median class. So we have already identified the median class, and the lower class boundary here is 60.5. N is the number of elements in the data set, which is 60, which we know already. CF is the cumulative frequency of the class preceding the main class. So this is the median class that we have, and this is the class which is preceding it. So we're going to use the cumulative frequency of this class here, represented by this term CF, and F is the frequency of the median class. So we're going to make the use of the cumulative frequency of the class above the frequency, the median class, and the frequency of the actual class. So here we do the computations. Median is calculated as the lower class boundary of the median class, which is 60.5, n divided by 2, n is 60 here, minus 30, and we get 30 minus 30 as 0. So this whole expression comes out to be 0, and we multiply it with h. H is the width of the class intervals. And since these all of these intervals are equally have equal widths, we have 20 for this median class also. So we multiply all this together and add up wherever it is needed. After computing this expression, we get the median computed as 60.5. In order to compute the mode of the group data, we need to find the class containing the mode, and that is very easy to compute. In your data set, in your frequency distribution table, we are going to find out the class which has the highest frequency, and you call it the mode interval. Here we can see that this class interval has the highest frequency, so we identify it as the model class. And then we use this expression to compute the mode for this the frequency distribution table. This is L, which is the lower boundary of the model class, which we have identified at this one, plus F1 minus F0. F1 is the frequency of the model class, which is this. F0 is the frequency of the class preceding the model class, which is this one. And F2 is the frequency of the class after the model class. So after an H here is the width of the class intervals, which we know for this case is 20. So after computing all of this for this data set, we get this value 72.5. 60.5 is the lower class limit represented by L. F1 is the frequency of the model class, which is 18 in our case. F0 is the frequency of the class preceding the model class, which is 9 in this case. And F2 is the frequency of the class after the model class, which is 12. Since we know that the model class has the highest frequency, we know that this value can never turn out to be negative. So we multiply it by this expression by the width of the class, and we get 72.5 as the mod value.